My name is Bob Vawter. I work for Google on the Google Web Toolkit. I'm one of the engineers who is a full-time employee on the system, and I've been with that team for about a year and with Google for about 3 years. So what I'm going to talk about today are some new features that we're currently building up in the incubator project, and as well a new feature in GWT 1.5, the release candidate having been announced today and is available for public consumption. That we'll be talking about resource bundling as a general technique, as well as a particular implementation of resource bundling that we're calling immutable resource bundle, or foo bundle for short, as well as the linker architecture, which is new in GWT 1.5. So to start off with, I just kind of like to reiterate what is the Google Web Toolkit. And it's a platform. It is a collection of tools and libraries and techniques. And this platform allows you to build high-performance Ajax applications. And this tool set that I'm going to be talking about today, again, fills in with the GWT mission that by giving developers the ability to effectively bundle and manage the resources of their applications, you can make a better application. By building out this linker subsystem in the 1.5 release, we give developers to do very new and different things with the output from the GWT compiler. If you need your own kind of bootstrap mechanism, if you want to do particular integration stories, then that's where the linker architecture gives you complete control over what the output of the compiler looks like. So just a really quick overview of what to expect to see in the presentation. We'll start with just a very quick, the 5 things you need to know about what the GWT compiler does when you run a compilation process. Then we'll have sort of 2 halves talking about resource bundling, some techniques there. And then I'll get into linkers and kind of walk you through. Linkers are best explained by examples. So I'll just sort of go through some very simple examples from actual code that you can go download that is in production today. So what you need to know about the GWT compiler. Basically, the GWT compiler reads your gwt.xml files and it reads in your Java files. Then maybe it makes some more Java when you see those gwt.create calls, and that's what we're going to be talking about primarily today. It reads in Java, maybe it makes some more Java, then it does lots of magic. It will optimize, it'll cross-compile, and then you'll get a whole bunch of JavaScript out on the other side. The actual Java to JavaScript process isn't particularly important for this conversation, so we'll just kind of, call it magic today. After you have all of the JavaScript that's been created by running the cross-compilation, it will invoke a series of linkers. And these are the things that are new in 1.5, and they will take the compilation artifacts, all the public resources, the generated resources, the JavaScript, and other things, and they will produce the final output of the compiler. And this is completely pluggable. Just some, really quick definitions. Linkers operate on artifacts. There is one primary linker, and all of the other linkers either run before or after that, pre and post. But we'll come back to this slide. Okay, so resource bundling as a technique. We have a web application. It has, in addition to just the JavaScript code that is running at runtime, it may depend on a wide variety of different kinds of static resources, image files, little bits of HTML, snippets, sound resources, anything like this that are static that you have at compile time. You can start to apply different kinds of bundling and optimization techniques when you run the compilation process. And what's kind of fun is that when you adopt this resource bundling techniques, you can start to improve the efficiency of your application and defining efficiency in different ways for different applications. That is, if my application is data-driven, that is, I need some JSON data or some text files to read in and parse, and that causes things to be displayed on the screen, having these resources available bundled into the application can help to improve the time to ready. That is, when the application, the code is ready, it's processed all the data that it needs to, and now the user can interact with it. So we're always talking about reducing the number of round trips required to make your application go. And resource bundling is a technique that you can use to reduce the number of HTTP round trips required. What's also fun is once you've adopted sort of programmatic access to your resource, that they're not just strings embedded in your application, you can do all kinds of cool stuff when you run the compiler. That is, your I-18 substitutions become really trivial because you just have a hook point when you're already defining these resources. That widgets can adopt a dependency injection style of coding to pass the resources in. If you make a really neat foo widget and it needs some, little decoration graphic files, a lot of times you have to deploy this and you just assume and you force the developer to provide graphics at a particular, relative path to the application that I might have, images / upper left-hand corner .gif. Well, that's kind of annoying to me as a developer consuming your widget because what if I'm already using an images directory? What if I already have something named upper left corner .gif that I have no real way to change how your foo widget operates because I can't inject the resources into the widget when I construct it. And the other nice thing about tooling is that as things evolve over time, as browsers change, or as the particular kind of deployment you're doing will change over time, you can change the infrastructure behind the abstraction that you're using so that you don't have to go through and modify every part of your code that deals with resources. You can do it in a centralized place, and you can take advantage of the tooling. So, in terms of actually implementing any kind of bundling system, either be it foo bundle or something you're building on your own, is that you'll want to use the GWT generator system, which is the primary means of extending the GWT system. It's where a lot of the magic happens. RPC, I-18, all of these things are done with the generator system. That in order to build your own generator, you simply implement that base class. It is a publicly accessible class. You implement the generate method, and you kind of go to town from there. And generators can range from things as simple as building glue code to associate data objects with UI widgets and wire up, setters and getter glue code. Or you can do wholesale synthesis of totally new functionality, such as the declarative UI system that's being worked on in the incubator. The generators have access to the entire Java type system. So any of these sort of extrinsic information about a resource, like where it is at compile time, or other attributes that you want to apply to that resource, those you just are encoded in the Java type system as return types or parameters to other things, or using annotations with Java 1.5 language support. And when you are writing your code, all you simply have to do is do gwt.create of your resources class, and that will trigger the generator to run. Ray Cromwell especially has written a lot of public blog entries about generators. I think he's also got a presentation here at Google I/O, and those are some very excellent resources to look at as you're thinking about generators, to give you sort of more background information. So as a particular implementation of resource bundling, we've been building out a system in the GWT incubator, which is a public Google Code project. We're calling it Immutable Resource Bundles, or foo bundle for short, because Immutable Resource Bundle is far too long to pronounce. And, the design goals that we want to achieve are listed here. But a lot of it just has to do with taking the best practices that we've already established in terms of deploying, GWT modules and applying them to resources that we want perfect caching of these resources on the client. Leverage the compiler, use all those optimizations. Localization is very, very important. How many folks on the web don't speak English as their native language? You want to be able to target these markets very effectively, but as part of your development process, you don't want to have to be overly burdened by the mechanics of actually localizing your application. But some explicit non-goals for the system that we've built are that we're not trying to give you something that looks like a file system. These are, when you use them, actually just going to be Java interfaces. You could very easily build a file system abstraction on top of this, but file systems and all of the baggage that they imply would be a little bit too heavyweight for what we wanted to build in this first iteration. We're also explicitly not including access to dynamic resources, things that are not available at compile time. Again, we're trading runtime complexity for limiting the use cases a little bit in this first iteration. Integration. It has to be easy to use in order to get our developers to want to use foo bundles. So it really kind of boils down to about 3 steps. You inherit the foo bundle GWT.xml file, just like you do with in your normal GWT.xml file inheriting user or whatnot. You'll wind up declaring an interface that encapsulates the resource. If you've already used image bundle, this is the same technique. It's just a more general application of defining an interface that declares the resources and tells the compiler where to find them at compile time. And then in order to access the resources from your application, you just call gwt.create and all the magic happens. You as the developer, as the consumer of these resource bundles, you don't care where the resources come from, how they got there. You just accept, hey, I have an implementation of my resources class, and I can get the resources out of it. So, very important because I-18, because localization is very, very important. I want to bring this up, sooner rather than later, to basically just say that the system as implemented is sensitive to the locale property. If you're already using GWT I-18 support, this is a natural extension of that the value of that locale deferred binding property is simply applied to the resource names that we look for at compile time, that we just do a best match, or you can do token substitution, again, with a best match kind of thing. So it's very easy to incrementally add new languages, add new locales, without actually changing any of the code that consumes these resources. So going back and talking about perfect caching, one of the big optimizations that we apply all the time to the modules themselves, to those cache.js files, to the cache.html files that you see all the time. We want to continue to use that same sort of technique with your resources. That, it's very convenient in your code to have a string literal that says, images / upper right-hand corner.gif. You would definitely not want to go in and hard code all of these strongly named files into your code. But because you're accessing these resources through an abstraction where I have a, data resource.get URL, at runtime, you don't care what the URL is. You just want to know that it exists and the data is there and accessible at that URL. That you continue to use those cache forever headers, that these file names change every time the content of that resource changes. And on browsers that support them, we can also take advantage of data URLs to actually inline the contents of that resource directly into the JavaScript or into CSS or into a text file. Compiler leverage, very, very important. It's the reason why we have the toolkit is because we have a compilation system. We can do all kinds of neat and fun stuff. That by taking intrinsic metadata about a resource and embedding it into the application, we can get all kinds of nice optimizations at runtime. Like, say you have an image resource. We can already know the exact width and height of that image when you compile it. So that when you're creating DOM elements, they are already the right size, that you don't get that kind of jittery effect as the browser is downloading images and potentially resizing your DOM elements. That is an incremental optimization to a program that just makes the thing work better for users. That everything is already sized right, even if the browser has not yet downloaded the images. Code pruning, code optimizations, inlining of, constants and things like that throughout the application, you can wind up with actually very, very little emitted JavaScript because the compiler is as aggressive as it is. So let me give you an example of how you use this. This CSS resource is already built. It's already in the incubator. I'd love to get feedback on it. So we can do fun things like, CSS is sometimes a little bit difficult to work with. That you can't do things like define symbolic constants, that sometimes you use these really crazy selector syntax to target one particular browser over another. it's frustrating, and it leads you away from what you're really trying to do. Even just to be able to rip out comments in whitespace and make them free at development time without paying those bytes at runtime. We can do all kinds of fun transformational tricks on your CSS at compile time, and we leverage things like deferred binding. So you'll get different versions of the CSS for different browsers if you happen to use these if statements. Any kind of framework that we build has got to be, generally extensible. That as we add new resource types, I started with text resources and data resources, and then, CSS and images were just additional things added after the fact without actually redesigning the core system. That kind of extensibility is very important to any sort of library that we want to provide and continue to support in an ongoing basis. So that when you compare this to image bundle, that is, image bundle has one containing type that all it contains is images. But what we want to do is change the model a little bit so that now you just have a type which embeds resources. That you then just define the type of the resource by the return type that you declare that accessor function with. That a text resource returns a text resource object. That CSS returns a CSS resource object. That, as capabilities evolve, for handling particular types of resources, we just simply add on to the API that these resource interfaces provide. That, right now CSS can give you, obfuscated style names, things like that. But we might want to actually evolve that in the future and maybe allow styles to be completely dynamic at runtime. That these functions will give you access to the underlying CSS rule in the DOM system for you to manipulate in the future. And by using, a Java type system, by using Java library design and building the system, we're able to give ourselves room for future expansion that continues to remain source compatible with the things that you've already written. So, going beyond just static resources and that particular implementation of immutable resource bundle, there are other things, the more dynamic data that you might want to bundle, not necessarily into the application, but into the outer HTML page. That is, in order to launch the GWT module, I have to go grab an HTML page to get the script tag that brings in the module. But a lot of your GWT modules, your GWT applications that you're building are very data dependent. They're driven by server-side data. Imagine, if you will, I have some site, I have to log into it, and users have their own preferences. When you download that host HTML page, wouldn't it be really cool if you can embed the user's preferences in the same round trip that's providing that outer HTML page? Because you already know who they are. You may as well save yourself the additional round trip after the module starts to go ahead and provide that data. So a very simple and easy way to do this is to just embed a JSON-style object into your host HTML page in a script tag. Simply, assign a JavaScript object to some well-known variable name on the window or wherever you want. Then you can use it with the new JavaScript object wrapper types in GWT 1.5 that basically allow you to write type-safe JavaScript at compile time, but pay no runtime overhead for these types. They're type overlays. And you can use this to provide structured access to this little snippet of JSON-like data at runtime. That the module, once it's up and running, can basically just say, okay, go get me the preferences payload object, and then I'll go ahead and pull this data in and set up my application. And it saves me from having to do a round trip from the module to go fetch the preferences, to then do something else, to maybe, go make more round trips required. So, when you have a sort of a mixer-style application where you've got a whole bunch of different data that's relevant to a user's interaction, you could go, put the preferences in the page, and you could put like the data that comprises the initial page view into the page, or not. If the data is not ready yet, you can ship the outer HTML page back with only a limited amount of the data, and still be able to make that round-trip RPC request after the module starts, so that you can at least provide consistent timing, even if you can't provide all the data all at once. If you're already using GWT-RPC, you can apply the exact same technique of bundling that initial payload into the outer HTML page. It's basically the same technique as inlining a chunk of JSON type data, but you're using the serialized GWT-RPC version of your object graph. For this demo, let's assume that you have a myRPC interface, that it has some method defined on it that returns a type of my payload. So you would construct on the server side, in a servlet or in any other kind of Java-based processing system. There's a publicly accessible utility method called RPC encode response for success, and you can basically just say, okay, here's an object graph, an instance of my payload. Take it and give me the string that is the serialized version of this object graph. And it'll do its thing, and you get a string. And you can take this string literal and simply stick that into the outer HTML page as a string constant. Then, normally where you would write, gwt.create in your client code, gwt.create of the myRPC interface. In the same way that you would cast the asynchronous object to the service dev target in order to set the URL that it accesses, there's another interface that these implement called a serialization stream factory. And you can basically cast it to serialization stream factory, and now you have an object which can deserialize and serialize any objects that RPC interface could normally serialize. So I can basically say, create me a stream reader out of that string literal that you'd put into the outer HTML page, and then read the first object from it, because there's only one object in the stream. I guess that's how you called encode response for success. And what's fun with that is, again, you can continue to use GWT-RPC with the Java type systems, and it's a very natural way of programming if you're already using RPC, but apply that optimization of bundling that runtime data into the host HTML page and saving yourself an RPC request, or 2 or 3, depending on how much and what kinds of data that your system requires to operate. So that kind of comprises the first half of the sort of resource bundling techniques. And what I'd like to do is talk about the linker system that's new in 1.5. And then we'll see also at the end how the linkers can then be integrated back with generators. And this produces some very interesting combinations. So what are linkers? If you are a C++ developer, you've probably, you take your CC files and you turn them into .o files, and then you run the linker over all the .o files, and out pops a binary. In terms of how the GWT compiler works, we have a kind of a similar model where you have these public resources and maybe resources made by generators that might be bundled resources. They might be image strips or transformed bits of CSS. That you have, any kind of other metadata about the module, like what scripts does it depend on, what style sheet should be injected, things like this. These are all artifacts that after you have run the Java to JavaScript transformation, those big chunks of JavaScript are just other artifacts. That something somewhere has to take all of these disparate things and combine them together into what will comprise the final output of the GWT compiler. Previously in 1.4, we always made a GWT module. They always looked exactly the same. But with 1.5, the whole process of taking all of these disparate artifacts and turning them into the output is now completely pluggable by our developers. That you can make linkers, you can make optimizations or transformations on the output that are very specific to your production environment. That we as a provider of a library and a toolkit, could not make, because they're correct only for you, that we can't apply them to everybody. But that, you yourself can go and add these sort of deployment strategies into the linker system. Everything in the output is put there by the linker stack. Nothing comes out of the compiler into that output directory that linkers did not put there. And because you have control of the linker stack, you control everything in the output. You can make it look any way you want to. So the linkers that are built into GWT 1.5, we are basically just there to provide different kinds of bootstrapping and packaging. You have the standard iframe linker. If you don't do anything in your gwt.xml file, this is what you get. It produces cache.html files and a module.nocache.js. It's the same bootstrap system you've used in the past with 1.4. With 1.4, we had also introduced that module-xs, the cross-site version of your module. That logic has actually been moved into its own linker, the XS linker. You will simply just do an add linker, name equals XS, and now you've got the cross-site output without having all that duplication of cache.html and cache.js. The output directory has gotten a lot cleaner. There's a lot less stuff in there, and it's very targeted based on the particulars of the linker and the deployment scenario that you're using. We've also introduced a brand new way of bootstrapping and packaging your application, and that's the single script output. And what this will do is that it takes your GWT module and the bootstrap and it jams it into a single JavaScript file. But the drawback is that you can only have a single compilation result, that you can't have any unbound deferred binding properties. So you can't necessarily make a version that runs on IE and Safari and WebKit or other browsers with having a selection script in there. But what you can do is when you have library stuff, when you have reusable chunks of JavaScript logic that you want to share with other people that don't need to interact with the DOM, you don't need deferred binding. So what you can do is you can link in the single script output linker. And then what that will do is it will give you a single JavaScript file that you can stick on your website and other people can download and go to town with. And they don't really care about, there's no need for a two-stage bootstrap system. It looks just like any other JavaScript library at that point. And the whole linker mechanism is intended to be extensible by the GWT developers. All of the classes and types and things that you need to make it go are located in the core ext linker package. It's in the Java doc. It's all public. These interfaces are basically going to be stable. With the caveat that GWT 1.5 is the first release we've done this with, and we might evolve things, especially based on feedback, once people take this linker concept and start trying to do real stuff with it. We've just kind of had to imagine what could people do with it. But, the feedback from the open source community has been very, very excellent at evolving the way that the GWT system works. So, I have this tool, I have this hammer, what am I going to do with it? What's the right kind of nail to bang on with this hammer? So just as a means of explaining by example, you typically want to build a linker if you need to make the behavior of your module dependent on like the file names of other things. Like, let's say that you want to build a manifest file for use with Google Gears to make your application go offline. Well, the funny thing about GWT output, because we subscribe to this perfect caching model, the file names might change every single time you run the compiler. So in order to build that manifest, you have to already know what the names of all the files in the output directory are going to be. So what you'd be able to do with that is write a linker that sits at the tail end of the linker chain and takes, okay, here are all the files in the output, and now I'm going to make one more file that is the managed resource stores manifest that knows all the names in the output. This is actually in the Google Google API library, the GalGWT project, in a module called offline.gwt.xml file. We'll actually look at the implementation in a little bit. When you want to integrate with environments, that aren't just a regular plain old web page, gadgets, portal systems, containers, things like this, where you need to have the bootstrap of the module aware of this richer environment that you're operating in. That when you write a Google gadget or an open social gadget, you have a wealth of runtime behavior that actually makes bootstrapping the module a lot simpler. You can take advantage of this. You can package your application as part of the compilation process simply by having a linker at the end that maybe builds your gadget descriptor. This has, again, already been built out as GWT for gadgets. It's in the GalGWT project, and we'll take a little bit of a look at how it's implemented. And just in general, whenever you want to have really good control over what the output, how the output is structured. Maybe it's packed into a WAR file and it's already ready to go with the descriptors and the web.xml file. Or if you're just trying to solve like a general, I need to make the GWT output, instead of being round, square, so it fits in this hole for my particular deployment scenario, it's really to solve that I want to use GWT and some other product. That this is where you can get some of that leverage in order to make the GWT platform work for the other 20% of cases that don't just look like a regular web page with a regular chunk of JavaScript. So just a little bit of background and terminology for linkers, the component parts. Linkers operate in terms of artifacts. An artifact is just a Java type hierarchy. Then we have the compilation result, which is basically the big chunk of JavaScript, as well as the values for the permutation properties. Like, this is the JavaScript for IE. This is the JavaScript for Safari that's compiled for French. That we have a set of types, emitted artifacts. That these are basically an input stream associated with a path in the output. That, you can tell resources that were part of the public path, just your sort of static resources at compile time, versus resources that were made by a generator, like if you're using FooBundle or the image bundle system, that the little script tags and the style sheet references that were in the GWT.xml file are also represented by artifacts. And that's to allow your bootstrap sequence to, download and inject those script tags, inject the style tags as necessary. That all of the data that we need to make a regular GWT module works is available in the artifact set. It's available to you as a writer of linkers. Additionally, generators can cooperate with linkers. If you're already familiar with generators, in the generator context, you can just say commit artifact, and you can make your own subclass of artifact, and it'll just show up later in the linker stack. And you can send a whole bunch of data, just arbitrary Java objects from the generators into the linkers so that things can cooperate. That's how GWT for Gadgets works, and we'll see a little bit of a demo of that. And then there's also the linkers. You basically just think of them as transformational logic. An artifact set comes in, an artifact set goes out, and then that set is passed on to the next linker in the chain. If you've written filters or anything in that vein, this should be a very sort of intuitive programming model for you. That the artifact set that comes out of the final linker, all of those any emitted artifact in the final artifact set are written to disk by the system automatically. And then just the random other kind of metadata, global stuff, that shows up in a linker context, which your linker is initialized with. So you'll see some of these types in the code snippets that are coming up, and I just wanted to kind of let you know what's what. So here is the absolute simplest linker that you can build. It does absolutely nothing. But this is how you build a linker. That is, in a GWT.xml file, either your top level one, or if you're using, module inheritance, you just have a defined linker. You associate an identifier with a class name. And, then at some point later, you have an add linker. And these are distinct so that if you're building a library of reusable widgets and linkers and other kinds of stuff, that you don't force the user to actually have the linker going just by inheriting your XML file. I mean, in some cases, like with the Google Gears manifest support, the offline.gwt defines and adds the linker. But this allows you to tune the use cases for how you want to present your library to other folks. And then the actual implementation of the linker, there's a base class called abstract linker. It provides a number of utility functions for taking strings and creating synthetic artifacts that get written to disk, for creating strongly named files, just utility kind of stuff. Typically you just extend abstract linker and you get a bunch of stuff for free. Linkers have to have a human readable description just for the logging purposes. And then there's the link method. Again, it's kind of stuff comes in, stuff goes out. And that's the general flow of linkers, that they're just lined up one behind the other and things go to town. You'll notice that there's an annotation linker order, and this one's set to pre. There are pre-linkers. There's one primary linker. Every time you do an add linker of something that is a primary linker, it replaces the previous one. So that's how you would replace the normal standard iframe linker, which is a primary linker, with your own if you need a custom bootstrap system. Similarly, the cross-site linker, the single script output linker, those are also primary linkers. So when you do the add linker, add linker name equals SSO, the single script output. It basically just does the right thing. You don't have to think about how, when, or why it works. So here is, so we in the gal-gwt project, there's offline.gwt.xml. You basically inherit that file. You call one utility method, and your GWT application can run offline with Google Gears, insofar as just having all the resources available. You're responsible for all the other logic, but at least getting you to the point where you have the infrastructure to go offline is basically 2 or 3 lines of code. In the offline.gwt.xml file, again, we define the linker, and we go ahead and add it, because there's really no reason to inherit this module and not use the linker, because then you wouldn't have the manifest file generated. In the declaration of the Gears manifest linker, it's defined as a post linker, because we want it to run at the end of the compilation process, at the end of the linker chain. Its link method is pretty much straightforward. Now, you'll notice the first line there has toReturn equals new artifact set. The incoming artifact set is immutable. If you try to modify it, you'll get an unsupported operation exception. And basically, we did this to give ourselves a little bit of leverage in the future for determining how to expand the linker architecture. Right now it's a single chain, but you can imagine that if we wanted to, you get to some point, then you have 2 different sets of outputs, and then it bifurcates. Giving us the option of having these, immutable incoming objects gives us a little bit more room to maneuver in the future. So you can't write a linker that depends on side effects from other linkers operating at different points in time. The incoming artifact set, it has a find method. It just says, find me all the emitted artifacts. And only emitted artifacts are things that are written to disk in the output directory. So now you have all of the emitted artifacts. It happens to be a sorted set, because all of the linker-related things that return collections return sorted collections. And this is nice because your logic that you write just needs to iterate over these sorted collections, and you're guaranteed to have stable output between identical runs of the compiler. You don't care that the hash code changed because this object got mapped to a different part of memory. It always looks the same for every identical run of the compiler. Then we just, there's a utility method in the Gears linker that just says, emit the manifest that contains entries for all of these emitted artifacts. That's on the next slide. And then at the bottom, we will just, emit a synthetic artifact that are the bytes of some string that we have created. That emit bytes is one of those utility functions that is defined in abstract linker. You just, give it a set of bytes and a partial path that is, where in the output should this thing be emitted. And at least for offline, we just have the manifest name being the name of the module .nocache.manifest. So, especially when you're talking about Gears, execution order of linkers relative to one another is very important. So what we've tried to do is make the system behave like you would expect if you just sat down and write it. Linkers, again, are divided into 3 bins: pre, primary, and post linkers. One primary linker, adding a new primary linker simply replaces the old one. Pre's and posts will accumulate as the gwt.xml files are expanded. And, generally speaking, pre-linkers run in lexicographical order in which they are seen when the gwt.xml files are evaluated. And post-linkers run in reverse definition order. Again, this little snippet here just kind of gives you the relative ordering that the first pre-linker runs first. Any inherited linkers run after that first linker, and so on and so forth, that you can see the relative ordering of the linkers on the slides. In the general case, you don't really care about this because you probably have only 1 or 2 linkers in your entire chain. But if you did get into a really advanced use case and you cared about the actual order, it is well defined and it is documented. So, again, back to our favorite topic of reducing the number of round trips for your application. Right now, I have a host HTML page. Normally, you load the module simply by, having a script tag, which includes the no cache file. But let's say that you find yourself in a deployment scenario where you don't need the typical perfect caching scenario. Like, maybe it's on a file system. You're just reading these things off of disk. Well, maybe you want to reduce the amount of stuff in your directory. So you can use a linker to inline that no cache script into the outer HTML page. That, again, the flow should be very similar, that we loop through all of the emitted artifacts and we look for things which look like HTML pages. And then anything that looks like an HTML page, we look for all the script tags in it, and we see if we have another emitted artifact that has that name, and if so, we take the contents of that JS file and we just stick it into the HTML file. And the flow here should be hopefully pretty simple to look at and just get the feel for the coding style, if nothing else. That you'll take the file, you'll perform the string manipulation, the string replacements, and you'll replace the original HTML artifact with a new artifact, because all artifacts have to implement comparable, the standard Java collection interface comparable. And what you'll do is emitted artifacts happen to be comparable by their partial path, that is, their location in the output. So if I create a new emitted artifact whose name is foo.html, and I re-add that to the artifact set, it'll replace the old one. So you can do additions, removals, and replacements of artifacts pretty simply just by doing normal set operations. And this, again, is sort of a second half of that slide, that we're looking at the replace scripts method, that this emitted artifact E here is that HTML file that we want to perform. We simply read the contents out as a stream, and we turn it into a string with just a simple utility function. We do all the HTML parsing or regular expressions if you're feeling really lucky, and then we'll create a new emitted artifact whose contents are simply the string that we happen to be manipulating, with the same partial path of the original artifact, so that when we stick it back into the artifact set, the original one gets replaced. So other people, may have a deployment scenario in which they want to do their permutation selection on the server. Especially if you already have a very robust serving system that is already aware of, is this IE, does this look like Safari or whatever. Maybe you don't want to use our no cache file, our selection script, and you want to do the selection on the server. Well, all you really need to do to make that work is just know which of these chunks of JavaScript corresponds to which permutation. So you could write a linker whose sole purpose in life is simply to export data about the compilation so that you can do something else with it later. And this code's a little bit more, baroque to look at, but the point is that linkers don't necessarily have to have any transformative value on the artifacts. They can just create new, exported data reports about the system if you wanted to. But, again, if you did not want to use our no cache script because it's appropriate for you, just, you'd have to build this yourself. It's not appropriate for GWT necessarily to provide this kind of functionality, because it's specific to a particular deployment. But if in your situation it's the best thing to do, this gives you the leverage to be able to go in there and change how the bootstrap works. So GWT for gadgets is a combination of a generator and a linker. That is, we wanted a programming style that leverages the Java type system for the metadata about, this gadget needs, the set title facility, and this one needs the Open Social API, and so on and so forth. That we want to be able to derive the information about the runtime environment from the Java facilities that the application actually consumes. So what we wound up with is this programming style where we have a generator sandwich. You have a base class that you extend, but then we go and generate a subtype of your particular gadget type, into which we do a sort of straight-up dependency injection of the features that you need. Code's on the next page. But the other thing to point out is that you need to have written a gadget.xml file so that the container knows what it can and cannot do with your gadget. Again, we want to derive that from information in the Java type system. So we use a generator to extract information from the type system, and then it gets passed on to a linker, which does the final assembly of the gadget.xml file, because it has to already know what the names of the JavaScript chunks are. This is some sample code of how you actually write a gadget in the GWT for gadgets case. That I just say extends gadget, implements these needs features that I need the intrinsic features like get cache URL. I need the set preferences feature. I need the set title feature, and I define little injection points. And at runtime, you are just assured that you'll get implementations of these feature objects. That we take things like module prefs. This is an annotation, but it shows up in that gadget.xml file that you get at the very end of the output. Additionally, with preferences as well, preferences, when you're writing the Java app, you need programmatic access to the preferences, and we also want to be able to derive the entries in the manifest file from the types of preferences that you declare in your particular subtype of the user preferences object. Again, the gadget linker is actually simply a specialization of the built-in cross-site linker, but simply instead of rolling a nocache.js file, it rolls a nocache, gadget.xml file. So, it's almost the same. It's just a little bit different. The packaging, the naming is a little bit different. So we're pretty much at the end of the presentation. Hopefully I can take a couple of questions. But here are just a couple of keywords for some additional reading. If you do a Google search for GWT for gadgets or immutable resource bundle or GWT linkers, you'll find reference material on this. Certainly, Ray Cromwell's blog. I think it's Timepedia. Yeah. The path to 1.5 on Ray's blog also covers some of these topics as well. Additionally, if you have questions or comments, after the fact, the Google Web Toolkit Google group is a good place to hang out. We also have some, GWT regulars who hang out on freenode.net in the GWT channel. We've got 3 minutes for questions. Oh, it's # GWT? Okay, well, okay. So I think I can take 1 or 2 questions if you have any. Otherwise, we'll wrap it up. Question in the back?
Are there tools to allow distributed processing through the Gears local databases and to handle those type of sessions, kind of in the GWT structure for that?
Yeah, the gal-GWT binding for Gears exports the worker pool interface, and then you can one of the driving factors for that single script output is to build Gears worker modules, so that you can take a linker and you can build a Gears worker module that's simply ready to go with the bootstrap that is necessary for your system.
And do you have a tie-in for, say, if I have multi-sessions, large groups of those, if there's failover, is that on your infrastructure where like Bigtable and MapReduce, is it sessions for that? Are they handled from there? Is it kept there or it's kept local, right?
I'm sorry, I didn't.
So really say I have a pool of Google Gear apps, right? I've got them data processing maybe 100,000 different pieces, modules of data, and I've got sessions running on the main server, kind of telling me, and then they keep reporting in when they finish. So like if there's a fail, say if I'm doing an app engine app, does it have redundancy that it'll keep the sessions?
You're talking about Google App Engine?
Yeah, if I'm using Google App Engine as a main server to kind of like handle the data there.
No, I mean I was referring to the Google Gears worker pool threads.
Right.
I don't know enough about App Engine to answer that with any kind of.
All right, I'll ask the App Engine guys later.
Yeah.
Cool.
Okay. All right. Yeah, I think that'll have to be the last question.
You talked about saving round trips through embedding RCP data in the initial download.
Yes.
Is that already written and available somewhere?
There are a couple of examples of that. I can probably just whip up a demo app as part of building out the documentation for this, for the final 1.5 RC. We still need to build out the documentation there, and certainly an example application. A variation on the Dynatable sample would certainly be worthwhile to explore that more fully. So we're at the end of the time here. Yes. Okay, so yeah, Ray Cromwell's Google I/O presentation, GWT Extreme, which is tomorrow or whenever you want on YouTube, will cover linkers in more depth, and he'll show you some more advanced examples of using linkers. So thank you very much for your time. Have a nice day, and good luck.